Okay, right? So over here, we talk about a vector. It has a magnitude and direction. You are given any vector, you draw an arrow. The length represent the magnitude, and the direction is represented by the angle. Normally, you measure from a reference point. So you measure from positive x-axis, for example, in this case, right? And if you know A, you can find negative A. Basically, you'll be going opposite direction, keep the same magnitude. Negative 2A, you double. So head to tail, no problem?
No problem.
So you just move the second vector, right? And I'm going to give you a few other vectors. I'm going to put C, and then this angle is 30 degrees. So assume this is length is 2 centimeter, okay? And the D is also 2 centimeter. So you will see that this is 100, right? So if you measure the angle, will be 180 degree. 180 degree will be pi, right?
Why does 180 degrees equals pi?
180 degree is the same as pi radian. So if you go through one complete circle, we call it one revolution. What's the angle?
So 330.
Yeah, 330. This is 360, right? 360 degree, which is 2 pi radian, right?
Yeah.
And so you will get 30 degree convert to radian. What would be 30 degree in terms of radian? Do the unit conversion, be 360 degree times 2 pi. You simplify it, what do you get? Pi over 6 radian. Right? Good?
Yeah.
Now let me give you another example. You can calculate it for me. 45 degree, what's the angle in radian? 120 degree. You can do the calculation.
I think 45 degrees is like pi over 4 radian.
How do you get it?
And you multiply it by 180 degrees over pi.
Pi over 180, right?
Yeah.
Leo, what do you get for 120 degree?
It is
Do the same thing. You use 120 degree time,
100 pi over 180 degrees.
then simplify it.
So it is 2 and 3.
Yeah, 2 over 3 pi, right?
Yeah.
Very good. Daniel, how about 150 degree? How do you convert to radian?
150 degrees times pi over 180.
Yeah, degree, right?
And
Let's
yes,
simplify it.
and simplify it to 5 over 6.
5 over 6
5 over 6
pi radian.
radian.
How about 3 over 4 pi? How do you change it to degree?
Degree, it could be 3 over 4.
What do you get?
Square radii over 360.
Pi over 2, what do you get?
Pi over 2 should be
90 degrees.
90 degrees, right?
Yeah.
How do you set up the conversion factor?
180 degrees over pi.
So that's how you get 90, right?
Yeah.
Good. Abner, 3, 4 pi. How many degree? You can cancel out pi, right?
Yeah.
And then 180 divided by 4, you get 45. So you get 135 degree. Very good. Right? Just set up the conversion factor. Daniel.
this one should be 150. It's 150 times. Yes.
150 degree. Good? Yeah. This is how you do it. Good? Now you are given a D. You are given C. And then A, assume this is 2 centimeter. And B is also this 30 degrees. Okay? Over here, I just assume this is 60 degrees right now. And then B is also 2 centimeter. Okay?
Okay.
So A is 0 degree. Right? So I'm going to remove this one because that's your result. So what you need to do, you are going to find A plus B plus C plus D using head to tail. A plus B plus C plus D. What do you do first in this situation? You get A, you get B, right?
Yes.
Head to tail. You get A already here, B is already here, right? So what do we do? Can we move C here? And then what's the last one?
180 degrees.
Yeah.
And a straight line. An extension of C.
How do you draw your resultant right now?
Why we don't go this way? We'll go this way.
Because D is going this way,
All
right?
let's see the arrow.
That's a good question, right? So over here, your resultant is in this green arrow. Do you see that? That's called head to tail. So that's a head to tail. The second scenario, you are going to use a parallelogram. How do we use this parallelogram? So imagine you have vector A and then vector B is going this way. So right now, you draw both vectors starting from the same point. Do you see that? Then how do you find the resultant? You create a parallelogram. Then your resultant is going this way. This is A plus B. Does it make sense?
Yes.
Yes.
Okay. Suppose this is a C going this way, and then D going this way. Can you find C plus D?
What's the degree? Like the degree of this?
The degree? Yeah, it depends on the degree. 90 can be 120 or 100, right? That would be Pythagorean theorem, right?
Yeah.
Very good. So let me show you the scenario here. Now, you can use a parallelogram to find the resultant. A plus B plus C plus D. You can draw it on the screen.
How can I draw it if it's more than 2 lines?
More than 2 months, you start from one of them and then add one at a time.
Let me try.
This between C and D is this, right?
Mm.
Then what's next? B.
B
You
and
can
C.
see. Then it's not B and C right now. It should be B and it's a green part, green, right? Or else you will add a C twice, right? You will change in the result. So over here, if we have protractor, the ruler, then we can estimate the resultant between these two will be closer that way, right? Will be somewhere there. Right? And actually, you can tell when you draw, it's not accurate, right? So that's a better, we call it mathematical way. It's more accurate. You will see this mathematical way.
If they add up all the degrees.
Yeah, so you need to find all the components. So we are going to have this x, y axis. So you have vector A, this is theta 1. Vector B, theta 2, right? So vector B, I can use a different color so that will be easier. So I'm going to find x component. You project A on x-axis, you get AX. You project A on y-axis, you get AY. You see that?
Yeah.
And you do the same thing for B. You project B, you get BX. And you project B on y-axis, you'll get BY. In this situation, right? So I'm going to talk about this trigonometry function. Have you learned trigonometry function?
I don't think so.
Not yet?
Like cos,
Yes, not
sine,
yet.
and then 后看吉他.
Yeah, cosine theta, sine theta, tangent theta, right? Okay. If we didn't learn that, no problem. So assume this is an XY coordinate system. This is X, right? And then that's angle theta. This angle theta can be any angle. So how we define sine theta? Sine theta, sine of this angle will be equal to the opposite side, which is A over hypotenuse. This is hypotenuse. So this is the opposite side. For a right triangle, you know the two legs, right? This is A, this is B, this is C. Using Pythagorean theorem, will be C squared equals A squared plus B squared. So opposite two hypotenuse, right? That's a sine. And then what's the cosine? So you get cosine theta would be B over C. This is adjacent. Adjacent, it means that's on the side. So to adjacent is next to the angle. And then over hypotenuse. And we call it SOHCAHTOA. That's how sine theta, cosine theta, tangent theta was defined. And then this sine theta is SOH, right? SOH. Sine theta is opposite over hypotenuse. So you take the first letter. And then cosine, CAH, right, is equal to adjacent over hypotenuse. It's easier for you to remember. And tangent theta is sine over cosine over adjacent. Okay. So in this case, I'm going to give you some questions to work on. So let me give you some questions about these components, right? Abner, you can read the question.
What are the x and y components of the plane's velocity?
So this is V, right? This
12.
velocity is 40 meter per second. So how do you find the x component? And this will be your y component. So what is the Vx over V? Can you tell me in terms of 15 degree, is it cosine or sine?
This one is cosine.
Cosine,
Sorry.
adjacent, right? So Vx will be equal to V times cosine 15. So cosine 15, what do you get?
0.9723
Let me ask.
9204.
0.9659258262.
I also get 0.9659.
Yes.
So you'll get around 38.6 meter per second. Now, we do the same
What?
thing for y. Vy over v, what do you get? Is it sine or cosine? So it'll be
No.
sine 15 degree times 0.2588. So you calculate it, you will get 10.4 meter per second, right? You good?
Yeah.
Any questions so far? So now let's do one more question. So look at this one. Can you calculate it? 35 meter per second and 57 degree from x-axis. And you can join and find the x and y component. And then 35 meter per second, 57 degree. Leo, find the x and y component first. This is x, this is y-x.
One is cos 57, one is sine 57. Cosine 57.
Vx over v, is it sine or cosine?
Okay, that's it.
Is it cosine, Abner?
Yes.
Yes.
Cosine
57.
0.446.
degrees equals 0.5446.
Oh. And then time 35, right?
Yes.
Set up equation for y, Vy.
For one, it is sine 57.
Mm.
It is
So-
0.83867.
That's good. So you'll get Vy will be V sine.
0.83867.
Then you calculate it, you will get the answer, right?
29.4.
Question 1a. Then you draw
Minus-
and you need to add the two vectors. These are x, right? These are y, right?
Yeah.
And then the first vector, 5 meter per second. Suppose this is a 5 meter per second.
45-degree angle.
This is 45. And then 2 meter per second, 180. Where is it?
180 degrees.
You draw in scale, right?
Yeah.
That's 0 degree, right?
So what is this?
And then you may draw 2 now because these are only 2. That's a 5. You draw in scale. So in this case, how do you add these two vectors?
Head to tail?
Yeah, head to tail, but it won't be accurate, right? In order for you to find the magnitude, right now we are going to draw a table. So suppose this is a A and then this is a B. It's good. So can you find X? Over here, this is AX, this is AY. This is BX, this is BY.
I think cosine for 45 degrees is 5. Oh no. 0.70711067.
Is it AY equal AX?
Yes.
Because it's 45 degrees and y is 90, so it has to be 45 and 45. So it's some ratio to 1 to square root of 2.
That's good. So if it's 45, you will realize X and Y component, they are equal, right? So this is cosine 45 is square 2 over 2. It's A, right? So 5 times, so it'll be 5 times 0.7. Then around 3.5, right? So we can put it here. This is around 3.5. 3.5. Now, how about BX? Daniel, what's BX? What's BY?
2 times cosine 180. So that equals -2.
Cosine 180 is -1. So time 2
Yeah.
will be -2. It's projected on the negative axis. You put -2, right?
Yeah.
Then what's BY?
Equals 0.
Because it's a line on the x-axis. What's the sine 0 degree?
Also 0.
Is it 1? So you're using this 3.5 minus 2, what do you get? 1.5.
Yeah.
And then 3.5 plus 0, you get 3.5, right? And then right now you get A plus B. This is X component, this is Y component, right? So how do you find the magnitude of A plus B. You use the Pythagorean theorem. 1.5 square plus 3.5 square. You see that?
Yeah.
Do you understand why? So this is X, this is Y, this is a 5, for example. This is a 2. So over here, this is AX. So this is your resultant, right? So how do you find it? And then over here, this AX minus, this is BX. Because it's going opposite direction. You minus BX, right? That's why you get A plus BX. So right now, your final result going this way is the Pythagorean theorem of AY squared plus X squared, right? So that's why you use the Pythagorean theorem. So you get this small triangle here. So this is the Y component. This is AX plus BX. Then this is a right triangle, right? So your resultant will be equal to this square plus this square. So you get C squared. So C will be square root of A squared plus B squared. And trigonometry function, you know how to apply?
Yeah.
Awesome.
Yeah.
You guys are so good.
Yay!
Yay.
Let me tell you my secret. This answer is wrong.
Huh.
Mm-hmm.
Huh.
So you draw a table, okay? That's X, that's a Y. So you find the X component for A, find the Y component for A, find the X component for B, and C.
Oh,
Is your
I-
point? Is it this? Is it 0.87 here?
0.8660 about.
So Leo, you do A, right?
Okay.
And then Abner, you do B. Daniel, you do C. So sine 15, right? Sine 15.26.
They're like
Banner.
And B
the parallel.
97. 96597. Okay?
Sin 30 degrees times 40 equals exactly 20.
That's a sine. So you want to realize sine 30. What's a sine 30?
0.5.
1/2.
30 is
3 over
0.8
2.
something.
Yeah, square 3 over 2. And then B, this will be 90, right? Abner, what do you get for BX?
It's like 86.93.
86.93. Okay. Then how about Y component?
Negative 23.29.
26.29. Or 23.39, right?
Yeah.
Mm-hmm. Okay. So again, it's good you put a negative here because the Y component is going down, right? Now, Daniel, what's a CX? What is special about going straight down?
So you don't have.
Straight up the
So
13.54? This C is 60, right? Going straight down. Does it have X component? You project it on X will be 0, right? Cosine 270 is 0. Cosine 90 will be 0, right? So this will be 0. Over here, you get very close. So you put negative 60 here. Right?
Yeah.
Nice. Now, can you add this? So AX plus BX plus CX, you get RX using this. So what do you get? 34.64 plus, what do you add? 93. And then you add a 0. What do you get here?
121.57.
That's good. Then how about Y, right?
29.
29. Okay. So this is CY. You add it. So this is 121.57. And then Y would be negative 63.29. Right?
Yeah.
Then what's in the resultant? So if you draw, this is 120. So theoretically going this way, X, right? So go this way. Do you agree?
yes.
So this is 121.57, and then this is going down negative 63.29. Right? Now you need to find this angle. You use a tangent theta equals RY over RX, right? So theta will be arctangent of this 63.29 divided by 121.57. And then this one, how do you find the angle? You use a second in your calculator. And then remember to put, did you write down? When you do the calculation, do you get around 27.5 degrees?
Yeah.
So what is the south of east? We're going this way. So you get 27.5 degrees. This direction is east, right? Going down here is south. That's why you go from east going south 27 degrees. That's why is called 27.5 degrees south of east. So you start from east, going south. It's south of east. Or another way to answer the direction of angle would be. So if you know this is 27 degrees, can you tell me what would be this angle? What would be this angle theta? If you know this is 27.
90 minus 27.
This is 63. The answer, it can be 63 degrees east of south. You got it? This will be the same as 27 degrees south of east. And then you use the Pythagorean theorem to find the magnitude will be 137 degrees, 37 meters, right? So free fall is falling. So what's the acceleration for free fall?
9 for Earth,
Mm,
9.8 meter per second squared.
9.8 meter per second square.
No air resistance and some questions.
And acceleration due to gravity is 9.8, right?
Yeah.
Which scientist figure out free fall?
Galileo.
Galileo Galilei, right? What did he do? He
We
dropped
know
two different balls with a different mass from the top of the pizza tower, right?
Yeah.
You remember that, right? So they fall down with the same time, right?
Yeah.
Same time. And then later, this is the situation.
Neil Armstrong
Where do they do the experiment?
on the moon.
Yeah, they did it on the moon and figure out the feather.
Gravity is
Different, same.
From Earth.
That's very good. So in this situation, you want to
We've all watched it before.
It landed on the exact same time.
at the same time? Yeah, this is on the moon.
Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel. So that this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest.
So it fall exactly the same time. Do you see that? So what conclusion do they make on there?
All objects in free fall do accelerate in the same rate.
What rate?
9.8 meter per second squared.
And then, do you remember why is it negative?
Because it's falling down.
Yeah, going down, right? So you use a negative 9.8 meter per second square, which is a negative 10, right? For easy calculation, normally you can use it. What do you see here? What do you see here?
It's going.
What happened?
It's drawing a line.
How?
It's accelerating.
Mm.
It's going when speed up.
So every second, the velocity increases by the same amount. What's the same amount?
So acceleration.
Yeah, that's 10 meter per second. Every second, the velocity increases the same amount, 10 meter per second, right?
A cannon shoot a cannonball up and then fell down again.
You go up. So in the beginning, it was slowing down first and then speeding up later, right?
Yes.
How about this one? What do you think?
It'll be higher.
Why?
Way higher. Because the picture is longer.
Yeah, the teacher is not. What's the initial speed?
50
20.
meter per second.
Yeah, right? And then right now you have more initial velocity. Does it take more time to go up and down?
Yes.
Yes.
If you draw the velocity versus time, how does it look like? Can you estimate? How does it look like?
A curve,
A curve? Okay. What kind of curve?
like something like this.
I think it's like
Which one? This one? Happened? Huh?
yeah.
Oh,
I think it's like this.
What happened? Why is it like that?
Because it need to the cannonball shoots it also have a acceleration, but very big acceleration.
But
A
does
short
the
time.
acceleration change?
No.
What's on
Velocity.
y-axis?
Velocity.
Yeah, you get velocity. What does the slope of velocity versus time give you?
Acceleration.
Does the acceleration change?
No.
That's why it has to be straight line, right? It cannot be a curve, right? Earlier, you draw a curve. What is it there for?
Speed, not velocity.
Yeah, that's just position, right?
Yeah, that's position.
Yes.
Why is it straight line? Why there's an arrow going up?
Because when the cannonball shoots fires, it have a very great accelerations.
Position. This is going down directionally, right? So position will go this way, right? Okay, next. What does this point represent? Where is it? Where is it located?
Here.
Maximum height, right?
Yeah.
And the maximum height, what's the velocity?
Here.
What's the velocity and maximum height?
0.
0.
The acceleration is 0 meters per
Zero.
second. Swear.
Daniel, what's the acceleration and the maximum height?
The height is 0.
What's the acceleration and the maximum height?
It is, I think it's 9.8 meter per second squared.
Why?
Because all the time the gravity is acting on it.
So you are Superman. When you throw it and it go to the space, then your acceleration will be 0. Abner, right? Daniel?
Yeah.
Both of you are Superman. Yeah, you throw this object and it go to the space, acceleration will be 0. As long as you are still on Earth, so acceleration due to gravity doesn't change. Now, how about this one? How do you draw this graph? You go up first and then come down. So what's the difference, right? The first situation, you go up first and then come down. Oh, this is still going down. You go up, right? Go up and then down. And then Leo. Then the second situation, you go down.
You really want to play superhero, don't you? Well, let's see if you can fly.
Sure.
Is it possible for him to catch the object,
No.
right?
Yes.
So it will be 9 this way. 9 this. What happened?
It's the same acceleration.
So what happened to the distance between these objects?
The same.
It's the same.
Universally the same.
The distance between these two objects is the same.
Yes.
Okay. Now let's do this question. Okay.
2 identical bowling balls, A and B, are each dropped from the top and a tall tower is shown in the outline below. Ball A is dropped 1 second before ball B is dropped. They both fall for some time before ball A strikes the ground. Their resistance can be considered negligible. During the fall, after ball B is dropped, but before ball A strikes the ground. Which of the following is true?
Then
C.
your answer is C. Abner?
Yeah. At the choice.
D?
Yeah.
Okay.
So I think it's E2, D.
What is it? You got D too?
I think it's E. I think it's E.
Leo, you got E? Why is it E?
Because the acceleration is the same.
Acceleration is the same. So let's analyze. So ball A is dropped before ball
So
B.
ball A is always faster than ball B.
This is ball B, right? So what's the difference between A and B?
Only just A drop first, B drop second.
So A 1 second, A is here, right? 2 second, A is here. 3 second, A is here. It's okay? Now how about B? 1 second, B is here. So A is dropped 1 second before B, right?
Yeah.
And then what's the 2 second? 2 second B is there, right? And then 3 second, where is it? And then 4 second. So at 1 second, H1. What's the equation to find H1? Daniel, what did you say?
I did say, I said,
Half GT square, right?
yes.
This is half G times 1 square, you get 1, right? How about 2 seconds? 2 seconds will be half G times 2 square. What is it? It's a 4H1, right? 3H1. You see that? Now, can you tell me T equals 3 seconds in terms of H1? How far does it go? Delta Y. This will be 4H1. T equal 1 second is 1H1. T equal 2 seconds, you get 4H1. So from 1 second to 2 seconds, it goes through 3H1. Then T equal 3 seconds, what is the delta Y? Do you get confused?
Yes, a bit.
So you start from rest, right?
Yeah.
And what's the initial
Initial speed is 0.
0? Then T equal 3 seconds. What is the delta Y? What do you get here?
10 times 9 divided by 2 equals 45.
So you get 9H1, right?
Yeah.
Right? Then from 2 seconds to 3 seconds, how far does it go?
1 second.
1 second, how far? Delta Y. What's the delta Y here?
9.8.
9 minus 4. What do you get? 5H1. Do you see that? What happened? First second, you go through H1. What's the second one? Second, you get 3H1. How about third second? Can you tell me what's the next from 3 seconds to 4 seconds? How far does it go in terms of H1? What do you get? From 2 seconds to 3 seconds is a 5H1, right? Now from 3 to 4 seconds. Then you can find at t equal 4 seconds. What is it? 4 squared. What do you get? 16h1. Does it make sense? Then 16 minus 9, you get 7h1. Do you see that?
Yes.
So you get, do you see the pattern? 1h1, 3, 5, 7. What's the next one?
9.
9. So can you tell? So when A is here, 1 second, B is here. So the distance between these A and B is h1. But second, the distance between A and B is 3h1. The third second, the distance between A and B will be 5h1. So the distance between the two balls increase. You got it? Now, how about velocity A with respect to B? Velocity of A with respect to B, it means VA minus VB. Does it change? This part I think is more difficult for most of you, right? Right now, we finished comparing the distance between A and B. So you all know that every second, the distance between A and B increase, right?
Yes.
Now, which equation can you use to compare velocity between A and B? Which one? How do you compare the velocity right now? So we still assume start from rest. V equals 0, right? Then can we use a V final equals V initial plus GT? So that's 0. Does it make sense? So this location V1 is G times 1. But what's the VB at 1 is G times 0, right? And then at 2 seconds is G times 1. At 2 seconds here is G times 2. Right? So do you see that at the same time interval, VA minus VB is it always 1G? Is it always 1G? So velocity of A with respect to ball B doesn't change. Remain the same. No. Do not, right? Okay. So this is G times 3, right? So do you see that? So G times at 2 seconds, you use 2G minus 1G. At 1 second, it's 1G minus 0. At 3 seconds, it's 3G minus 2G. So you get 1G. Does it make sense?
Yeah.
You good, right?
Yeah.
Any questions so far? So let me show you what you need to do. Is okay? Your homework question.
The first one or second one?
The first one, you only need to finish before this problem. Projectile, we will talk about later. Okay? The vectors, can you do this question? Question 8, finish this table, okay? And then question 6, the other one, like question 3, pick some question to practice. And then you do this one advanced, right? You tried it first. Because I do have relative velocity and projectile question here. Okay?
Okay.
Daniel, which one did you finish?
I finished the whole second page.
Oh, second page. So which one, any of you has a problem? Do you want me to help you go through? This one asks you at what time the car is at rest. So what time the car is at rest? That's where your x-intercept. Your v equals 0, right?
Yeah.
X-intercept. And then how about this one? Now, what's your final position? Will be x final minus x initial. You are looking at 9 seconds. So how do you do this one? Question B, how do you do it? I want to show you how to do it.
Question.
You are looking for position and you are given velocity versus time. How do you do that? You use the area under the curve. Do you get confused? So you can see this 9 and over here this is 5 and that's 6, for example, right? And then you can estimate here this is a 0.9, a 0.8.
Oh.
Then you can find the area positive and the negative. That would be your displacement, change in position, right? And then don't forget to plug in the initial position 2 meters. Then you can find the final position. So you guys can continue to work on that.